Now let us discuss solution to solution number 3.2, problem set 3.1 on parallel forces and couples. So from Engineering Mechanics by Professor Timoshenko D.H. Young and Director J.B. Rao and Sukumar Pati. Now look at the statement and the diagram. This is the original diagram given in the book. A rigid bar CABD. This is a rigid bar. The length of this side and the length of this side, they are not equal. Is acted upon by two equal horizontal forces. At point D, there is a horizontal force P to this side. At point C, one horizontal force to this side. These two forces are equal and opposite. Calculate the reactions that will be induced at the points of support. Here is a point of support, here is a point of support A and B. We have to find the reaction here and here. In the points of support, given that the length from A to B is equal to 1.2 meter, from B to D, that is A, that is given as 0.9, and from A to C is given as 0.6 meter. So, supposing, so that is what I have explained here, the given data, the length from here to here 1.2, from here to here 0.9, from here to here 0.6 meter. Suppose these two horizontal forces are not applied, then the reaction at A and the reaction at B will be vertically upward due to the action force, the weight of the rigid bar. The reaction at A and the reaction at B will be vertically upward, provided these two forces are not applied. Now let the reaction at A, at the point A, is represented as RA, and the reaction at point B is represented as RB, right? Now let us see whether they are in the same direction or they are opposite to each other. Let us first analyze that. Since this length is more than this length, this horizontal force P will have a turning effect that will be equal to P times A, and this horizontal force P will also have a turning effect that will be P times A. Now P times A will be more than P times B. P times A will provide a clockwise turning effect, and this P times B will provide an anti-clockwise turning effect. Since P times A is more than P times B, so the overall effect will be clockwise. So the overall effect will be clockwise. So that is what I have explained. Since A is greater than B and P times A, which is a clockwise turning effect, is greater than P times B, so it tries to rotate clockwise because the clockwise turning effect dominates the anti-clockwise turning effect because A is greater than B. So to balance it, an anti-clockwise couple is required to balance that because it is in a balanced condition. So that therefore the conclusion is the reaction at A is vertically, the reaction at A here is vertically downward, right? So that this is to be understood why it has to be vertically downward, to provide a anti-clockwise balancing torque, because this clockwise torque P times A is more than P times B. So we need, so the reaction force at A has to be vertically downward. So let us apply sigma y is equal to 0. Since it is in equilibrium, therefore RA is equal to RB. Why it has to be vertically downward, that I just explained, to balance it. Now, so applying the sum of the forces along the y-axis 0, so reaction at B and reaction at A are numerically equal, but they're opposite. Now let us take the moment about the point A. You can take the moment about the point B also. Now, so RB times the length L. At this point, the reaction force is acting vertically upward. So RB times this length is a anti-clockwise turning effect, and P times B, this P, not this P, this P times B is also anti-clockwise turning effect. So both are added, and P times A, this P times A, because this A is the perpendicular distance. I am taking the moment about point A. If you draw a horizontal line, the line of action of this P from the point A has a perpendicular distance A. So is equal to P times A. So now take this to the right hand side is subtracted, take this L to the right hand side is divided. So take P common, so we are left with A minus P, put the value of A, put the value of P, put the value of L, and divide this, you get it as 0.25 times P is your reaction force at B, vertically upward. And therefore, the reaction at A is also the same, 0.25 P vertically downward. So I hope it is clear why the reaction at A has to be vertically downward, because to balance it, right? Because it is in equilibrium. So that is all about. If you like the discussions and explanation well, feel free to like it, and if you have not subscribed, you can do so and pass on to your friends also. Okay, thank you.